So remember back when we started this series, in the first lecture, we talked about Newton's first law. And we said his first law tells us that if we have some object moving with a velocity v, that if we look at it later and there's no interactions happening, that we'll find it in some other place, but it'll still be moving with the same velocity v. Right? Its direction and speed don't change at all if there's no interactions. Okay? Also remember, we talked about building models, right? And we said when we build a model that almost all the time this ends up being an approximation. We looked at, for example, a baseball that's falling down to hit the grass, and or a block sliding along. Like every time we talk about something, in terms of formulas, it's usually we're kind of glossing over a lot of the internal structure. And so these things are true enough to be able to calculate things with, but not really what's happening. So the interesting thing with Newton's first law, kind of the astounding thing, is this is not an approximation. As far as we know, and as far as it's been ever experimentally tested, Newton's first law is a universal law of nature. There has been no experimental evidence ever in violation of this. And in fact, when you read about physics experiments going on at like the LHC, where they're taking particles and they're colliding them together at tremendous energies, what they're really looking for in the end in these big detectors is they're trying to find missing momentum or missing energy, because that tells them that there's some kind of physics going on that we don't know about yet, because it's like that example with the blocks. If all of a sudden we do an experiment and we find out we're missing some momentum, that means we found something new. And sure enough, when you measure the bath water and you measure the weight of the box and everything, there's always something new hiding in there. So this is one of the tools that we have. Conservation of momentum really lets us explore physics at a very, very deep and very, very fundamental level, because of the fact that it's never ever been violated yet. Any violation is always explained by a block hiding outside the window, or any of these other examples we've been talking about. So keep that in mind as we begin this unit. Is this is something very, very fundamental, and I think it's very good that your book starts with this, because again, it's the first law of physics, and it's still one of the most true.